So the limit comparison test says, hey, take a limit as n goes to infinity of the two expressions that make up these series. And we'll call that, whatever that value that's going to be, we'll call that C. If C is positive, then either both series converge or both series diverge. So if you take this limit as a ratio of the two expressions, and if the value you get isn't infinity, if it's some positive number, then they either both converge or both diverge. Okay, so we need to know, I mean, this one looks like a p series, so we know this one's going to converge because n is to a power greater than 1, so this is going to converge. So if this limit comparison test works, we get a value for c, we know this is going to converge. Okay, so let's compute the limit that they've already set it up for us for a sub n and b sub n. We got 4 square roots of n over 9 n to the 9th plus 9. That's a terrible 9. And then we're going to divide that by 1 over n to the 17 halves. So we'd flip and multiply the second fraction. If you've seen my videos before, I think my handwriting is getting worse as I get older with this mouse. There we go. Flip and multiply the second one. We get something pretty, well, that's not bad. This is n to the 1 half times n to the 17 half, so that's n to the 18 half, so that's n to the 9th, 4 n to the 9th, over n to the 9th plus 9. Wow, they set it up so nicely for us. These powers are the same, right? So as n goes to infinity, we learned in pre-calculus that if the exponents are the same, then it doesn't matter what's happening over here. The limit is going to be a ratio of the leading coefficients because these are going to keep pace with each other. The only difference is going to be times 4 in the numerator times 1 in the denominator. So C is 4 for this problem. Okay, so this one converges, so we know a sub n must also converge. So they just asked us to compute that limit. I think all you need to answer is 4 then.